answers lie. Let's all take one deep dive into the world of science, technology, engineering, and math. Get your safety goggles, 'cause we're making things explode. Science is so fun, so let's take it on the road. Meet a young scientist just like you and learn all about what they do. We'll even learn science that's in the news through one-on-one interviews with SCFGLive and friends. Experimenting never ends. Now let's see what's in store. Just press play and get ready to explore. Ho, 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 hey, hey. Ho, 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 hey, hey, hey.
Hi, everyone. How are we doing?
Is there nobody in the crowd? Hello, is there ghosts in the crowd?
I think there might be. I don't hear anyone. Let's try it again. How's everyone doing? Woo!
Oh, I heard tiny baby ghosts.
A little bit better, a little bit better. I'm Hannah.
And I'm Francesca.
And we are so excited to be here at MIT's Open Space Programming today with all of you to do some super, super fun experiments.
Woo!
We are from an organization called Science Club for Girls, which is based right here in Cambridge. We run free after school and weekend STEM programs for girls in kindergarten all the way through 12th grade, which is very exciting. And
we also, during the pandemic, we got to start producing a television show. And guess what? You are all part of the television show today. We are at SCFG Live here at MIT Open Spaces, all right? So get ready to put on your best faces, and we're gonna do some fun experiments today. Just wanna thank everybody who has been part of SCFG Live, and we have 45 episodes online on Facebook, YouTube, CCTV, and Comcast Xfinity on demand, so you can look up any of our episodes and learn more, especially if you like what is happening today.
Awesome. And a quick shout out to CCTV, Cambridge Community Television. Everyone wants to wave at the cameras and say hello. We are on TV today, which is very, very exciting. And they also stream, as Francesca was saying, our SCFG Live program. So definitely check those out.
Absolutely. So I'm just going to ask for any of our young scientists to sit at any of our tables over here. And any adults, please go to the back. Today we are going to focus on our young scientists, especially because we got a full house today. So we want to make sure that all our young scientists have a place to sit. All right. So now you got to learn a little bit about us, but now we want to learn more about you. So we're going to play a game, okay? So when you hear something that you think applies to you or describes you, you're going to stand up. And if it doesn't apply to you or describe you, you're going to sit down, okay? Because we just want to know who's in the crowd. Are you ready to get started? There's no ghosts in this crowd. You guys are not ghosts. I need to hear you guys. Are you guys ready to start? Yeah. Woo! All right.
All right, so the first category is if you are in elementary school. Go ahead and stand on up. If you are in elementary school. Nice. These are our elementary school scientists. Nice work.
Are there any middle schoolers here? Middle school scientists.
And any high school scientists? Any high school scientists? I know we have one from Science Club over there. Thank you. There's our high school scientist, Olivia. Fantastic.
If you live in Cambridge, stand up. We have so many Cambridge scientists here today. Woo!
Very, very cool. This is my favorite one. If you like science, stand up.
Oh, yeah.
Awesome.
All right. I don't know. Maybe this is not as popular. If you like math, stand up.
Super, super important. I love math. If you like being creative, stand up.
Yeah.
Amazing.
And if you like explosions and experiments, stand up.
I would stand on the top of this table if I could. It's like my favorite thing ever. All right, and last thing is if you like asking questions and finding answers, go ahead and stand on up.
Woo, those are our scientists right there.
Very curious. I love it. All right, so now that we know who's in the room, before we get started with our, just tell us about what we're doing today, Francesca.
Today, we're going to be doing some spooky science. We're going to do experiments that involve physics and chemistry and a lot of spooky elements. Don't be scared. Nothing scary is happening today. The only thing that you should know is how scary good we're going to be at science today.
Very funny. Now, before we start our experiments, though, it's super important that we go over some safety rules because as you can see on your tables, they're going to be using a lot of different materials. We also have some fun materials over here for our second experiment. So it's important that we go over some safety rules to make sure everyone has fun and does the experiment correctly.
Okay, so as you could see, I'm wearing safety gear. Okay, I have my safety goggles on inside your aluminum bins, and now you can look into your aluminum bins. There should be a safety goggle inside for every single scientist here. So please take those out and put them on. It's important because we're doing chemical reactions today, and that means we are working with some liquids we don't want to get into our eyes.
If you already wear glasses, those are safety goggles, so you do not need to worry about wearing these as well. If you already have glasses on, you are one step ahead. Now, the other thing we need to do to protect ourselves is to grab our safety aprons. So, fantastic. All right, well, we are ready to get started. Are you ready to get started with the first experiment? Yes, I am so excited. What are we doing, Francesca?
All right, so we are going to be making ghosts float. Wait a second. Hannah, I have to ask you a question.
Yes?
Are you a witch?
Well, Francesca, I've been meaning to tell you for quite some time that I am actually not a witch. We're going to be using the power of science alone to make ghosts float. Do you believe this can happen?
Yes, I watched it.
Amazing, amazing. All right. Well, in order to do this, we are going to be using something called physics. And that's a kind of tricky word. So I'm going to say it. I'm going to ask you to repeat it after me. Physics. Let's try that one more time. Physics.
Physics.
Exactly. And now people who study physics, which is a big branch of science, are called physicists. Oh my gosh, that's even a harder word to say. So let's try that. Physicists.
Physicists.
Nice work. And physicists study something called matter and forces, which are the pushes and pulls that act on matter. But Francesca, wait, what is matter?
Oh, I know what matter is. Matter is what makes up everything in the world. You are made up of matter. I'm made up of matter. This table is made up of matter. These pumpkins are made up of matter.
Wait, but what about this cup?
That's made of matter.
Interesting.
Everything is made up of matter, and all that matter is anything that takes up space or has weight to it. Even the air that we breathe is matter.
Wait, there's no way.
Yes, there's absolutely way. Think about this balloon. It's flat, right? But when Hannah blows into it, putting more air into it, it's taking up more space. Even has a weight to it. It's very small weight, but still, it has weight to it. Was it me?
That was not me. Very, very sorry. Well, wait, so you're saying that I matter, Francesca?
Of course you
gosh,
matter.
That's so sweet.
And you're made up of matter.
Oh, that's amazing. All right. Now, not only do physicists study matter, but they also study energy. And today, we're going to be looking at a super cool kind of energy called static electricity, which is going to help our ghosts to float.
Absolutely. So we are going to be using static electricity to make our ghosts float. All right, so are we ready to get into the experiment?
Yes.
Absolutely. Okay, let's get ready.
All right, now static electricity, I'm sure you've all experienced before. Has anyone ever walked across a carpet and then went to go like touch something, maybe like your dog or a sibling, and accidentally shocked them? Has anyone ever experienced that before? Or maybe you've taken your hat off in the winter and your hair has started to stand up straight. Has that happened to anyone before? Yeah, that happens to me a lot. Those are all examples of static electricity.
So static electricity is all about opposites, okay? So we have opposite charges when we have static electricity. There's a positive charge and there's a negative charge. So when you have the positive and negative charge near each other, they attract each other and they want to go near each other, right? And then when you have two of the same charges, which are positive or negative and negative, they want to go away from each other. Okay?
Or repel is what it's called. So let's try that together with our hands. So go ahead and put your hands out in front of you. Let's pretend that your hands, one of them is a positive charge and one of them is a negative charge. What are they going to do? Exactly. I
There
see
you
a
go.
few hands that are going towards each other. Opposite charges, like a positive charge and a negative charge, attract or come close together. So let's try that. Positive and negative charge, what are they going to do? Come together, exactly. But what if our hands are the same charge? If we have a positive charge and another positive charge, what are they going to do? Yeah, they're going to go far apart. It's kind of like two siblings or two friends who are so similar that they just don't get along. That was me and my brother. And what if it's a negative charge and a negative charge? What's going to happen? Also, they're going to repel or go away from each other. So opposites attract and the same charges repel.
So remember when we talked about matter before? Matter is made up of atoms, tiny particles called atoms. And atoms are made of even tinier particles called electrons, which are negatively charged. We got protons, which are positively charged, and neutrons, which are negatively charged. Or neutral. That was my mistake. Neutral. So usually there's the same amount of these in each atom, so nothing really happens. And they're not really being repelled or being attracted to each other. They're just there. But sometimes when you rub two things together, like when we rub this balloon on clothes, on a piece of felt, or on our hair, it's going to steal some of those electrons, those negative charges, and bring it to the balloon. So then when we put it near an item like our hair again, our hair has all these positive protons on it, so it's going to be attracted to the negative energy that's here.
Pretty neat. So we're going to be using static electricity in this experiment to make our ghosts float. All right, let's get started. For this experiment, go ahead in your bins and reach for a piece of tissue paper. There should be 3 pieces of tissue paper in each aluminum bin. Go ahead and grab 1 piece of tissue paper. Hold it in the air once you have it, so I know you have a piece of tissue paper. If you're missing one, raise your hand and a mentor will come and bring you one. Amazing. I see this table has their tissue paper. I see this table has their tissue paper. I see this table has their tissue paper. Hold it tight because it's windy today. Nice. All right, the next thing you're going to want to grab in your bin is a marker. There should be a couple different colors. You just need one. Just grab 1 marker. And hold that in the air so I know you have your marker all set. Amazing. We have our tissue paper and we have our marker.
All right, you're also going to need a balloon. Can everyone grab a balloon for me? And put it up in the air if you got one. Awesome. I see a lot of people have grabbed their balloons. Shake them in the air. Awesome.
Fantastic. And the last thing that you will need today, actually, I think that's it.
A pair of scissors.
Oh, you will need a pair of scissors as well. So go ahead in your bins and also grab a pair of scissors. There should be enough for everyone. You'll just need one. If you don't have a pair of scissors, just go ahead and raise your hand and a mentor should be able to bring one over. We might be short a few, so you might have to share. Awesome. All right, the first thing you're going to do is you're going to go ahead on your tissue paper, you're going to draw a ghost. So go ahead and draw a ghost on your tissue paper. It can be whatever shape you want. It can have whatever face you would like. This is your ghost. So go ahead and draw a ghost on your tissue paper. Francesca, I think I'm going to give mine pink hair.
That's a great idea.
I think that would be kind of fun.
Mine?
If you are done drawing your ghost, the next step is going to be to cut your ghost out using your scissors. Go ahead and use your scissors to cut your ghost out. If you do need some help, please definitely raise your hand. You can have an adult come over and help you with this step. All right, everyone. Now that we have our ghost cut out, the next step is going to be to blow up our balloons. So go ahead and grab a balloon and blow it up. If you need help tying your balloon after you blow it up, definitely raise your hand and we will come around and help you. All right, everyone. If you have your balloon tied and it's good to go, go ahead and hold it up in the air. Awesome! Great work. All right, now it's time to create that static electricity to help our ghost float. So what you are going to do, you have a few options. You're going to need to gain electrons from somewhere to go onto your balloon. So you can gain electrons from rubbing the balloon on your head. You can gain electrons from rubbing the balloon on your shirt, or in your bins is a piece of felt. You can use this too to rub on your balloon. Choose one of those places to gain those negative electrons, your hair, your shirt, or the piece of felt. Rub it for a pretty long time. We need a balloon.
Oh, yeah, we don't have one.
And once you're ready to see those ghosts float, hover your balloon right over your tissue paper ghost and let's see if it floats. Rub, 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 rub. And let's hover it over our ghost. Ooh! My ghost is starting to stand up. If it doesn't work the first time, go back to rubbing your balloon again. Rub, 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 rub. And then let's see if it works to... Oh, look at that! My ghost is standing up.
It's floating.
It's a floating ghost.
Oh, some of
I see a balloon. I see a ghost that's stuck to the balloon. That is a perfect example of a static electricity.
There it is.
Nice work, everyone.
And now we officially have scientists who know about static electricity.
Very exciting. Woo! Lots of floating ghosts.
It's getting creepy in here and spooky.
Corey, do you mind grabbing a trash bag to collect the balloons? Okay. Awesome. We're going to try this out for a few more minutes, and then we're going to collect our balloons and start on our next activity. Nice work. I see that static electricity in action. Very cool. Awesome. All right. Time to move on to our next activity. So we just saw that ghosts can float using a static electricity. But in this next activity, we are going to make ghosts appear out of nowhere.
And we're going to be doing this using chemistry. Chemistry is one of the major branches of science. It's actually sometimes called essential science because other sciences use it in their experiments and in their understanding of those other parts of science.
Super cool. And people who study chemistry are called chemists. Let's see if we can repeat that after me. I'll say chemist and you say chemist. Here we go. Chemists. And in today's experiment, actually for the next two experiments, you are going to be chemists.
Absolutely. So we are also going to be doing something called a chemical reaction. A chemical reaction is when you mix one or more substances and it creates or makes something different or new.
Very, very cool. Now, this doesn't just happen in the chemistry lab. It happens everywhere. Has anyone ever baked a cake before? Let me see with a show of hands.
Raise your hand, you ever baked a cake?
Yeah. Baking a cake is a great example of a chemical reaction because we are mixing substances together to make something that is brand new, a delicious, tasty cake.
Absolutely. There's different things that you can see in a reaction that can tell that it is a chemical reaction. There is a couple of signs. What are signs that a cake has changed from when it started to how it ends? Does anybody know? Does anybody have any signs that a cake has changed? Right over here.
Ooh, we have like a texture change. It's not wet and gooey anymore. It's kind of solid. That's a great example. Yeah, go for it. It's baked now? Yes, definitely. I also notice sometimes there are some bubbles that form in my cake when I cook it. Bubbles are a great example of a chemical reaction taking place. It's showing us that a new gas is forming, which is really cool.
Absolutely. What else do we notice when we bake a cake? Does anything change in the room for you? Right over here.
Ooh, yeah, it gets fluffy.
It gets fluffy because of all those bubbles, right?
Yeah, it's nice and light and fluffy for sure.
The color changes, which is one of the signs that a chemical reaction has occurred. Great job.
Oh, yes, it definitely smells better. We notice a change in smell, which is another example of a chemical change or a chemical reaction has taken place. So the examples or signs that a chemical reaction has occurred are a change in color, also a change in temperature. Sometimes when we have a chemical reaction, we'll notice things getting hotter or colder. We have a change in smell and bubbles. Bubbles forming also shows us that something new was formed. So in today's experiment, we're going to be on the lookout to see if we notice signs of a chemical reaction taking place. All right, so for this experiment, you will need, please go ahead in the center of your table and grab a bottle that has a liquid in it. This liquid is vinegar, so it is not water. Please do not open this bottle. We will in a moment, but go ahead and take that bottle out.
there also might not be enough for everybody at the table. So you're going to have to share. If there's not enough at your table, share with somebody that is next to you so you could do the experiment together, like lab partners.
Awesome. The next thing you're going to do is you're going to grab a balloon, a white balloon from the center of your table, and also a marker, a white balloon and a marker. Do not blow up the balloon yet. Keep the balloon deflated.
All right, raise those up for me if you have them so we can see how many people are ready to move on.
Let's draw the ghost first. Awesome. I see some balloons and some markers up in the air. That is perfect. That's exactly what you should have with you. Balloons and markers.
All right. First thing that we're going to do, we're going to grab our marker. We're going to draw a face on this balloon. This is going to be our ghost that is going to inflate by itself. So you could draw, once again, any face you want. I think this time I'm going to go with something a little bit more happy.
Ooh, that's a good idea. I might make mine a scary face. You'll notice that the face is going to be pretty small, but I have a feeling it's going to grow over time in our chemical reaction, just like ghosts sometimes grow. A little scary. Francesca, let me see what your face looks like.
Here we got.
Oh, I love it.
This happy ghost right here. Happy to be here.
Once you finish drawing your ghost, definitely show people at your table what your ghost face looks like. Nice work, everyone. The next step is that we are going to add baking soda into our balloons. Now, this is a little bit tricky, so we're going to use a funnel to help us out. What you're going to do is you're going to grab that small container of baking soda in your bin, put the funnel in your balloon like this, and then pour the baking soda into your balloon.
The baking soda should be in a small container, and it is white like powder.
Not everyone's going to have a funnel, so you will need to take turns with the funnel. So do one at a time. Good question. Pour all of the baking soda into your balloon. All of the baking soda into your balloon.
Into the balloon. Yep, not into the water bottle. Do not open the water bottles yet.
All right, Francesca, I put baking soda into my balloon. It's your turn to use the funnel. Make sure after you finish putting the baking soda in that you keep your balloon upright like this so we don't spill our baking soda.
Yep, hold it at this very part right here. We're going to make sure nothing gets out.
Nice work, everyone. I see a lot of chemists in here doing experiments, and thank you for keeping those lab goggles on to stay safe.
I know, this is a great group of scientists. Everyone's listening to directions and keeping each other safe.
And awesome work sharing those funnels. Teamwork is super important in science. Do we have any predictions about what's going to happen when we mix our baking soda and vinegar? Ooh, I love those predictions. Go ahead, what's going to happen? We might have an explosion. Very interesting. Yes. Ooh, maybe the formation of a new substance called carbon dioxide. What does that mean is going to happen if we're combining two things and a new thing is forming? What's going to happen? Yes. A chemical reaction. Nice work. If you think a chemical reaction is going to occur when we combine the baking soda and the vinegar, give me a raised hand.
I think so.
Oh, this is going to be exciting. What does that mean is going to happen to our balloon? Do you think the shape of our balloon or the size of our balloon is going to change in any way? It might get bigger. Ooh, maybe a self-inflating ghost is going to happen. Very cool. All right, team. Now is time for the fun part. We are going to combine our baking soda and vinegar. Before you do anything, please watch Francesca first before doing your own. So I want to keep those caps on our bottles for now. Please watch Francesca first.
All right. You're going to grab your bottle. Remember, we're not doing it right now. You're going to watch me first. You're going to set it down. You're going to open up the cap and put it right next to there. And then you're going to put your balloon over the cap. Make sure that it is secure. And you're going to have right here, the opening, go over the other opening so that there's no space in between. All right? So this is the next step. We're going to set it up. And you're gonna make sure that the balloon over here stays flat like this on the side. We're not moving it to move the powder in. We're gonna keep it like this because we're gonna do it all together. Does that make sense?
Awesome. Everyone go ahead and put your balloon over your bottle. Make sure not to let any of the baking soda in yet. All right, if you're ready to give our countdown and you're ready for our experiment, give me a thumbs up. All right. Here we go, everyone. On the count of 3, we're going to count down 3, 2, 1, and then we're going to lift our balloon up to put the baking soda in our bottles. Here we go. Are you ready? Are you ready? All right. 3, 2, 1.
Go!
Woo! Oh my gosh!
We got some ghosts in the room!
Woo!
Very nice! Lift up your ghosts, let me see!
Does anyone feel a temperature change? Does anyone notice a temperature change? Look at that!
Make sure you're holding and keep your balloon straight up.
Whoa.
Do not tilt it.
I'm seeing lots of signs of a chemical reaction taking place.
Does anybody know the signs that a chemical reaction has taken place? Oh, we got a middle school scientist.
Yeah, we see some bubbles happening. Any other signs of a chemical reaction that we noticed? Oh no, yours popped.
Oh,
Sometimes ghosts pop too.
it was an explosion.
Did anyone notice a change in temperature happening? What did you notice? Did anyone else feel kind of a cold sensation? Yeah, remember, temperature change is another sign that a chemical reaction is occurring. So we noticed that it got a little bit colder. What happened to our balloon? How did our balloon change? Yeah. It did. Our balloon got bigger. That's because a gas was formed. A gas called carbon dioxide filled our balloon and made it blow up like this, our self-inflating ghost.
Yep.
Nice work, everyone.
When baking soda and vinegar combine, it makes carbon dioxide. Carbon dioxide filled up the balloon with the baking soda and vinegar combined. And what's that called again? Carbon dioxide is the gas. Great job. Does anybody know what the process is when two things combine to make something new?
It rhymes with... There we go, a chemical reaction. Nice work, everyone. All right, is everyone ready for our grand finale? We're going to make pumpkins puke. Can you believe it? And we're actually going to be using a very similar process of chemical reactions to make our pumpkins puke.
Absolutely. So before that, we're going to have to clean up our self-inflating ghosts. All right, so our mentors and junior mentors are going to go around with the big black garbage bags over here.
Do the finale if you want.
Do you want to do it?
And then clean up after.
Sure.
All right, actually change of plans. We're gonna keep your self-inflating ghosts. You can just leave them on the table if you'd like. That's totally fine. We're gonna go ahead with our chemical reaction grand finale.
Make sure if we're ready, we got to sit down at our seats.
Okay.
That's okay.
All right, everyone. Let's go ahead and get started with our grand finale.
All right, everybody. So, we are going to be doing a similar thing today. We have our two pumpkins here. We actually named them Mel and Jackie. You can see that they're a little nervous, and that's because they're going to puke. That never feels good. But don't worry, the pumpkins aren't really puking. We're just making another chemical reaction. Does anybody have any idea what two things that we're going to be using to do our chemical reaction? Does anybody know what did we use for our chemical reaction today?
What's going to happen? It's going to explode and come out. Yes, but what two ingredients are we going to use to cause our chemical reaction? Yes. You're
Vinegar
exactly right.
and baking soda. But are we going to need the same amount that we use for our small balloons for these big pumpkins? What do you think? No, we're going to need more vinegar and we're going to need more baking soda. All right, so let's get started.
First thing we're going to do is we're actually going to go ahead and add our baking soda. Oh, I lied. We're going to add our vinegar first. How much vinegar are we going to put in, Francesca?
We're going to put in 2 cups of vinegar.
That's a lot of vinegar. 2 cups? Oh my gosh.
All right,
It's going to be a big explosion. That's like a whole measuring cup worth of vinegar. Oh my gosh. All right. We put our vinegar in first. All right, here we go. Vinegar is going in our pumpkin.
All right.
Oh, I hope Jackie's okay.
I don't think
now
so.
what?
So now we're going to put some dish soap.
Ooh.
Remember what happens when our baking soda and our vinegar combine? What is made? It's carbon dioxide. Carbon dioxide! Oh my gosh, you guys are so smart. So when we put our bubbles, our dish soap in, when the chemical reaction happens, it's going to trap that carbon dioxide and make even more bubbles.
Bigger bubbles. Oh
So
my gosh.
We're going to put a lot of it in.
Oh, I hope so. The other thing we're going to add in is some color because puke is kind of a gross color, so we're going to make this a colorful puke. Any suggestions for what colors we use today? What color should we use for our puke? Yes. Purple. Purple's my favorite color. I'm going to add in a few drops of purple. Any other colors we should add? Green. I love green. Let's add some green. And let's do one more color. What should we do? Rainbow. Well, rainbow's a difficult color. I guess that means we're going to add some yellow. How's yellow? Good. All right. Oh boy, that's going to be some colorful puke. Okay, we have our food coloring, our dish soap, and our vinegar. What else do we need?
What's last? Baking soda! All right, I'm going to count down, and then Hannah's going to pour it in. Are you guys going to count down with me? Yeah. All right, let's count down to see Jackie puke. 3, 2, 1, let's see!
Oh my gosh, here it comes! Oh no, I hope she's okay.
Oh my goodness.
Is it coming out of the side?
Is it coming out? We can't even see it.
Gross. Oh, here it goes. This is disgusting. Ew.
Oh, you
God.
guys see that?
That's gross. Should we make this one puke too? Yeah. All right, what is the first thing we need to add? We don't need to add the baking soda. We're going to add the vinegar first. 2 cups of vinegar.
Should I add some more to make it a bigger reaction?
Add a little bit more. Why not?
So this time, instead of adding 2 cups.
How much are you adding?
I might add 3 cups.
3 cups! Uh-oh. First row. Watch out. No, it should be okay. 4 cups! Oh, no. All right, we have 3 cups of vinegar. Do we do our dish soap next? All right.
Our dish soap, lots of dish soap.
Oh, okay, that's a lot of dish soap. And now we have to add our colors. What colors should we use this time? Someone I have not heard from yet. Yes! Pink! Let's add in some pink. I love pink. And someone else I haven't heard from, yes? Brown. Do we have any brown?
I don't think we have brown.
We can make that work. Thank you very much.
But I could add green. All right, let's add some more green.
Fantastic. You will need to grab a seat for this. Thank you so much. All right, awesome. All right, so we have our food coloring, we have our dish soap, we have our vinegar. What is the last thing we need to add? Yes, baking soda. And this time, last time we added how much baking soda?
We added about a cup of baking soda.
All right, let's add, oh gosh, let's add a lot of baking soda.
Let's add a lot of baking soda.
Here we go. All right, last time I think I added only a half a cup, so this time we're gonna add in a little over a cup.
Okay, let's do this. Are we ready for this?
All right, let's count down from 5 this time, just to be safe. Are you ready? Here we go. 5, 4, 3, 2, 1.
Ooh.
Should we give it a little stir?
We should give it a little stir.
Stir it up with a marker. Whoa! Oh no, here it goes! Why not? A little more. This is a crazy, messy chemical reaction. What are some of the signs of the chemical reaction that you were observing here? What are some of the signs of a chemical reaction? Let's see. Does anyone see bubbles? Yeah, definitely some bubbles. And it feels really cold too, so definitely that temperature change. I'm gonna ask that everyone please stay off the stage. Thank you very much.
All right.
We will have an opportunity to take photos at the end, but you can definitely wave to the vomit for sure. Oh, and some color. We see some colors coming in. Very cool.
Remember, stay off the stage. This is
awesome
for
work, everyone.
Safety today. We gotta practice safety, so please listen to instructions and go sit back at your seats. Don't worry, we're gonna give a chance to get a picture with our puking pumpkin. Oh, Mel, I'm so sorry.
I hope he feels better. I think he just needs some rest.
Absolutely.
That's always a good thing. All right, so we covered a lot today. let's quickly review everything that we covered.
So, first we started off with some physics, and we did some static electricity by making our ghosts float. Remember, that's when the negative electrons are attracted to the positive protons that are on the other surface, and so it makes them attract each other and pull together.
We also talked about chemistry and chemical reactions, and we saw there's some really cool signs of a chemical reaction, like bubbles, a color change, a temperature change, and a change in smell. And we were able to inflate ghosts and make pumpkins puke. Really
Absolutely.
Cool. If you had fun today, raise your hand. Amazing! We had so much fun too. Thank you everyone for coming out. Thank you CCTV. Thank you MIT Open Space.
And thank you to you young scientists for coming out today and doing the experiments. Now you're all officially chemists and physicists.
Amazing. If you would like to come up and take a photo with the pumpkins, we're going to still ask that you stand at the end of the stage, but you are welcome to take a photo with your grown-ups. Thank you everyone.
Thank you everybody.